Coming up next, Mercy. Even though it might seem harmless, this little white box is capable of traversing all kind of terrain thanks to its 4 Daguwal thumper wheels, revolved by 4 12 DC motors. It is fast, it is agile, and it is strong. It can even carry your laptop.
Essentially, Mercy is a mobile robot that dreams of becoming a personal assistant for elderly people. To do so, it will have to become fully automated and new mechanical parts need to be added to its current design. However, as of yet, it is perfectly controllable via radio frequency controller.
She was designed thinking of elderly people because we consider that taking care of the ones who took care of us when we were kids is about the noblest thing we can do with our techie knowledge. Furthermore, it is important to recognize that as age goes by, a human's physical and mental capabilities tend to decrease, for which is imperative to safeguard elders from daily risks.
Mercy's structure is simple. Its outside shell is a rectangular wooden box that helps keep and protect its circuits. On its top, the little black device that can be seen is a LiDAR. Mercy hasn't learned to use it yet, but it is intended to serve as her eyes, for its laser will help her detect obstacles, measure distances, and create maps.
The rear part has 2 switches and a 3.15 ampere fuse to protect the robot from discharges. The yellow switch is the main on-off button, while the red one only affects the motors. Nonetheless, both switches must be on for Mercy to be able to move around. Notice that a small LED below each switch will shine bright when it's on.
Mercy's face currently has nothing but a hole. During this first stage, this serves no purpose, but later on, it will become a water and pills dispenser. Finally, Mercy's bottom has nothing but her 4 wheels and DC motors.
Right now, Mercy inside are composed only by its circuitry, but soon enough, a water tank, a rotating pie-shaped pill selector, and a dispensing mechanism will join the show.
In a nutshell, Mercy's circuit is made up of an Arduino, a couple of batteries, one for the motors and one for the Arduino, and 2 motor drivers to give speed and direction to each pair of motors. Currently, the Arduino board is Mercy's brain. It receives the signal from the RF controller and converts them into a PWM and digital signals to control the drivers. A Raspberry Pi 3 can be observed attached to one of the sides. This will allow Mercy to connect to the local network and to get information from a PC and the LiDAR, which will help her navigate.
Mercy's controllability is simple. There are 4 main commands that even a kid can memorize to be able to take Mercy anywhere. To move to the front and back, simply move the controller's left stick in the desired direction. Keep in mind that this stick also controls speed, for which the more the stick is pushed in either direction, the faster Mercy will go.
To make Mercy turn, give her some front speed with the left stick while moving the right stick either to the left or to the right. Make sure to push them all the way and remain pressing them until you want Mercy to stop turning.
Heroes never die.
Mercy now has additional functions that will allow it in the future to be a perfect assistance robot. At the top, a small compartment has been added where you can open and deposit on the 3D printed reel the necessary pills for the week. Also, below it, a box has been added for the front opening that existed, so it is now completely closed and allows for 2 different entries to either give pills or even water.
Mercy is meant to dispense pills for elderly people that are unable to move. In this part of the project, we want to keep the design simple and beautiful for our robot. The fan and the dispenser were 3D printed in PLA plastic and designed in SolidWorks. We made several attempts for the fan piece until we obtained the final design. Also, we investigated how to control the servo to drive the pill dispenser, and we found out that it can only rotate 300 degrees. With all this work done, we are getting close to the final results. We are missing important parts like the water tank inside the robot and the voice commands, but in the final project, Mercy will look complete.
Mercy is now able to map her surroundings. To accomplish this, 3 different components were used: the LiDAR, a Hector's lamp, and a static transform. Hector's lamp generates a 2D map based on the readings from the LiDAR. This technique is useful yet simple. as it does not require telemetry to operate. Instead, a reference frame is placed where the map starts to generate, and translation is calculated using the inputs from the LiDAR. The static transform is quite important too, as it allows Hector to perform accurate calculations taking into account the offset of the position of the LiDAR with respect to the base of the robot.
The teleop node is the link between the user and the Arduino. Developing this application as a second way to control Mercy was necessary for two main reasons. Firstly, even though the node currently works with keyboard inputs, it will later be adapted to work with a routing and control node, which will calculate and send linear and angular speeds, thus making Mercy completely autonomous. Secondly, it works great as a debugging tool, since we can control Mercy with precision through it without being physically close to her.
Mercy also now has a water pump on the side. One of Mercy's purpose is to provide water so that the user can take the pills immediately after he or she has received them. This pump will transport the water from a container into the dispensing area. As a physical addendum, Mercy now has two pads on the back, which have the purpose of conducting energy to its battery. This might allow the implementation of a charging station in the future, since charging Mercy doesn't require for it to be opened.
This delivery was challenging. Compared to the first installment, this was based on the refinement of errors and the creation of solutions to previous problems, in order to advance and almost achieve an autonomous operation with different functions that were already installed and tested, although they have not been fully implemented and will be left for the final release.
I am quite happy with the current state of the project, and though many things are still missing, like the control system for the wheels and the autonomous navigation, if we keep working hard as a team, I'm certain that we will end up with a great project.
With this partial delivery, we are moving forward the final product that we want. The object of this part is to prepare everything for the final delivery. Now, we only need to wait for the autonomous part to be useful. The work was smooth in this part, so I'm happy with the final results.
Having completed the second partial delivery, we can see with much more clarity our goal for this project. Even though this time we didn't have to create the robot from scratch, we had to implement complex functions to it, which took more critical thinking rather than physical effort. I consider this to be a more complicated task. I am content with the outcome of this delivery, not only with the new abilities of Mercy, but with the way we have worked as a team.
I believe this second development stage represents the key factor towards making Mercy autonomous. Now, she can use her LiDAR to detect obstacles and create maps, and the teleop node allows her to move around based on a set of inputs, which provides her with free mobility. Even though there's still some ground to cover, Mercy is now really close to becoming the fully automated assistant we want her to be.